Let's calculate the power of the complex number 1 minus I we see on the screen. This is raised to 3, and what we're gonna do is using Moivre's formula. And for this we have to calculate the polar form of this complex number. The complex number is z equal to 1 minus I. From here, let's obtain its polar form. First, we know that this complex number has a point, represents a point, and that would be the complex number can be expressed as 1 plus minus 1 times I. So the point would be the real part 1 and the imaginary part minus 1. Let's represent this point on the graph. 1 of the x and minus 1 of the y. So the point would be here on the fourth quadrant. This would be its vector, and what we have to do first is calculating the module of the complex number z, and it is the same as the module of the vector from the point 1 minus 1 to the origin. This is very simple. It is just the square root of the coordinates square, that is 1 square plus minus 1 square. This would be the same as the square root of 1 plus 1, the square root of 2. This would be the module, and now let's go with the argument. The argument is the angle that the vector forms with the x. Let's call this angle theta, and we can see that it is from the fourth quadrant. The tangent of this angle theta is always equal to the coordinate y of the point divided by the coordinate x. That would be minus 1 divided by 1. So the tangent of theta is equal to minus 1. Now let's look for an angle alpha that is from the first quadrant. So the tangent of alpha has to be equal to the same of the tangent of theta, but changing the sign, always positive. So it would be the tangent of alpha equal 1. Which angle has a tangent 1 on the first quadrant? That has to be known previously, and it is an angle of 45 degrees. And what this means is that if we reduce theta to the first quadrant, we would obtain 45 degrees. The formula for reducting to the first quadrant we would have is 360 minus theta equal alpha, that is 45 degrees. From here we would have theta equal to 360 minus 45, and that is equal to 315 degrees. So now we have obtained the argument of the complex number. Let's work always in degrees, but we could also have worked with radians. But now let's go on working with degrees. So this complex number in its polar form would be the module, the square root of 2, sub the argument, that is 315 degrees. This is the complex number z expressed in another form. So the power would be the polar number raised to 3. And now the rest, what we have to do is very simple. We just have to raise to the cube the module, and we just have to multiply the argument by the exponent. It's just that simple. So this would be the square root of 2 cubed is the same as the square root of 2 cubed, and this is the same as the square root of 8. And now the square root of 8 sub 3 times 315, it's equal to 945 degrees. And as we were given the number in its binomial form, let's express the polar form into the binomial form. So the formula for changing this is the module, the square root of 8 times the cosinus of the argument plus I times the sinus of the argument. What we're doing is just very simple. It can look as if it were very, very difficult, but it isn't. Just 3 or 4 simple steps and we will get to the result in a minute. Now let's calculate the cosinus and the sinus of 945 degrees. Let's reduce these big angles to smaller ones, so let's divide 945 by 360, and we would have 245 left on the division. So that means that we can express the cosinus and the sinus as the cosinus of 245 degrees and the sinus of 245 and 25 degrees. I'm sorry. Now with the calculator, the cosinus of 225 degrees is, and down here the sinus of 225 degrees is, as 225 degrees is from the third quadrant, the result would be, reducing the angle again to make it easier, the cosinus of 225 minus 180, and the same with the sinus, 225 minus 180. Let's look for the sign of these trigonometric functions on the third quadrant. And as x is minus and y is minus, the sinus is the y that is negative, and the cosinus is the x that is also negative on the third quadrant. So everything would go with a minus sign before. So we would have minus cosinus of 45 and minus sinus of 45. And this is the same as minus the square root of 2 divided by 2, and again minus the square root of 2 divided by 2. So now substituting this into the number, we would have the square root of 8 times minus the square root of 2 divided by 2 plus I times minus the square root of 2 divided by 2. Now multiplying everything, we would have minus the square root of 16 divided by 2 plus I times minus the square root of 16 divided by 2. So as the square root of 16 is 4, this would be the same as minus 4 divided by 2 plus minus 4 divided by 2i. That can be also be expressed as minus 2 times I, and this would be the result of calculating the power of this complex number by using Moivre's formula. We've done it in another way in other different video. bad. For small powers, this is the easiest way of calculating the power of a complex number.